Hello, welcome to my channel. I am Ameya and today we are going to discuss one problem for the non-weak form methods. Now those are weighted residual methods. Okay, in weighted residual methods what we basically do is we use various different approaches in which we will be having the approximate solution of a differential equation to simplify the theoretical procedure of solving the differential equation. So it is very easy, and once you understand steps how it's done, you can easily solve these various types of differential non-weak form type of problems using various methods. So in this video what we are going to talk about is we will be discussing about the initial stages, initial steps which you can perform for all the problems. We will understand the basics, and then we will in coming videos we will discuss about various different methods, Galerkin, Petrogalerkin, subdomain, least square, point collocation. All these methods we will see one by one for the same problem. So we are following this same problem for example. So the similar problem will be given in your exam, that d2y by dx square plus 3x dy by dx minus 6y is equal to 0 is a differential equation which is given. Then you have a condition for x. X is your independent variable and y is your dependent variable because we are derivating y with respect to x. So x is having a range of 0 to 1, and boundary conditions are given y at 0. So this means y when x is equal to 0 is 1, and y dash, which is a derivative, at 1. So x is equal to 1, y dash is 0.1. So we will start with our initial steps. Let me just take a pen. So we will start our initial steps here. Let me just zoom in a little bit. Okay, so let us start. So what will be my first step? So first step is about the approximate solution. First you have to assume the approximate solution. And how do we do that? There are various very basic steps to do that. First we need to find uh, order of a differential equation. Now how to find order of a differential equation? You just have to go for the highest order of differential available in the given system. Okay, so in this case it is 2. Okay, and then we have to assume the polynomial order. And what will be the polynomial order? Polynomial order will be always n plus 1. So if I say order of a differential is n, so this will be always, sorry, this will be always plus 1. So third order polynomial we need to assume. Now there are various conditions to assume the polynomial. So we will be assuming polynomial in such a way that it is a complete polynomial. Now what do we understand by complete polynomial? It should have all the order present in the polynomial. Okay, so if I am going for a third order which is a cube, I should have x raised to 0, x raised to 1, x raised to 2 and x raised to 3, all with a positive coefficients. That is what we understand by complete polynomial. So we will be assuming a polynomial y is equal to c0 x raised to 0 plus c1 x plus c2 x square plus c3 x cube. Okay, and the c1, c2, c3, c0, c1, c2, c3 are constants which we will be determining and solving for the differential equation. So this is the polynomial which we are interested in. Now another condition for polynomial is it should always follow the boundary condition. So you will be applying the given boundary condition for y. Okay, so whatever polynomial you assume, it should follow the boundary condition. Okay, so we will be applying these boundary conditions on our polynomial. Okay, so let us take our first boundary condition. Now what is my first boundary condition? First boundary condition is y at 0 is equal to 1. So if I substitute x is equal to 0 in this equation, what will happen? This term will become 0, this term will become 0, this term will become 0, and you will get C0 is equal to 1. Okay. Continuing with second boundary condition. Second boundary condition, you have given y dash at 0, sorry, y dash at 1 is given. So we will just check that. Yes, y dash at 1 is given. So we will enter that. Y dash at 1 is equal to 0.1, which is given. So we need to find y dash here. So what I will do is, how to find y dash? We will derivate this. Okay, let's say here. So y dash will be equal to derivating with respect to x. So this will be 0, this will be c1 plus 2c2 x plus 3c3 x square. This will be your y dash term, and condition is given that y dash at 1 is equal to 0.1. So what we need to do is, we need to substitute here. So 0.1 is equal to c1 we don't know, so we will be continuing with c1 plus 2c2 plus 3c3. Now here what we have to do is, we have to find the term c1 in terms of c2 and c3. So what we will do is, c1 we will take on one side, and we will take 0.1 minus 2c2 minus 3c3 as a value for c1. Okay, now you have a value of c0, you have a value of c1. What you will do is, you will substitute it in the equation 1, which is a y equation. So instead of 4 unknowns, what we have done is, using a boundary condition, we try to remove 2 unknowns. Okay, so the final equation of y which you get will be 1 plus 0.1, sorry, just a second, yeah, 1 plus 0.1 minus 2c2 minus 3c3 x multiply plus c2x square plus c3x cube. Okay, after simplifying this, you will get final term of y, which is 1 plus 0.1x plus c2. I will take common, I have two terms of c2, so it will be x square minus 2x, and c3 I will take common, you will get x cube minus 3x, and this will be your equation for y, final equation for y. Okay, so just to repeat the procedure what we have done, we have found the differential equation, order of a differential. Polynomial will be always n plus 1, so that will be 3. We have assumed the complete polynomial, we have applied a boundary condition, and we have found y in terms of c2 and c3. So there will be two constants. This will be your first step. Okay, moving forward, the second step will be assuming the residue. So we will be finding residue equation, residue R. Now if we are discussing about non-weak form, you can remember that we basically equate the residue with the given value. So the residue for this system, if your equation is given with this, as we are dealing with approximate solution, this will not be equal to 0, this will be equal to some constant R, and that is the error, so residue. So I am just writing that again, that is d2y by dx square minus, sorry, plus 3x dy by dx minus 6y is equal to 0, which is given, but this will not be the case, this will be not equal to 0, and that we will assume to be R, and we are interested in this R. Okay, so what we will do is we will continue solving. You already have a equation of y, so in this you can substitute, but you need to find this dy by dx and d2y by dx. So we will find that first. So let us find dy by dx, which will be 0.1 plus c2, differentiating with respect to y. So first term will be 0.1, the second term will be c2 into derivative of this, so that will be 2x minus 2 plus c3 into 3x minus 3, 3x square minus 3, because it is a cube, the derivative will be 3x square, 3x square minus 3. This will be your, just a second, yeah. So this will be your dy by dx. We also need d2y by dx from the equation. So we will try to find d2y by dx by derivating this whole term with again x. So first term will get cancelled. You will get 2c2 plus 6c3x. Okay, and what we will do is we will try to substitute this into the given term. Okay, so finally, if you calculate, what you will get? You will get an equation for r. Okay, so we are interested in the equation of r. So r you will get c2 into 6x plus 2 plus c3 into 3x square plus 15x minus 0.3x minus 6. This will be final equation of r which you will get. You just have to substitute dy by dx, d2y by dx and y in a given equation, equate it with r, and you will get this final residual equation. And we will be dealing with this residual equation in all the procedures which we are performing. Okay, this is the second step. Till this point, all the procedure will be same for all the types of problems. The third step is again very important. Here there will be a change. So third step is your weak form. Okay, so we need to find the weighted integral. So third step is about weighted integral form. And the form for weighted integral is 0 to 1, integral 0 to 1, wi r dx is equal to 0. So r we will be utilizing from the previous step, and this wi will change with respect to the method which we are implementing. It will be Galerkin, Petrogalakin, subdomain, least square, point collocation, any of the methods. So for this problem, the final equation of weighted integral will be integration 0 to 1. I will substitute wi and I will substitute r, which is c2 into 6x plus 2 plus c3, 3x square plus 15x minus 0.3x minus 6 dx is equal to 0. Okay, so till this point all the problems will remain same, steps will remain same, not the problem will remain same, the steps will remain same. The only difference will be the change of this equation. Okay, so these are the initial steps which we need to perform, starting with this finding the polynomial, finding the residue by equating with a given equation, and then finding a weighted integral form, integration 0 to 1 wi r dx. These three steps will remain same for all the methods which we are learning for the non-weak form type of methods. Okay, so in coming video we will be starting with a Galerkin method, So stay tuned. Do watch the next video in this series for Galerkin, Petrogalerkin, least square, point collocation, and subdomain methods. Okay. If you like this content, do subscribe my channel, follow my channel, and also share a word about the channel with your friends. Thank you for joining.